Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hi, ready to learn some more chemistry? Today we're going to talk about 5 types of chemical reactions. You need to know the chemical reactions in order to understand chemistry and also in order to predict products. Many times you'll be given chemical reactions with only reactants given to you, and you will be asked to predict products. Before you can predict the products, you first have to recognize some patterns. And if you recognize what type of reaction it is, predicting products is actually pretty simple. So let's learn about chemical reactions. Let's go to my screen. I think the best way to understand chemical reactions is to do an analogy. Let's talk about high school dance. There's always drama in a high school dance, isn't it? So let's go to scenario 1. In our scenario 1, we have A and B getting together into a compound. It's just like Adam and Barbara walked into the dance separately. They met on a dance floor, and now they are always together. You cannot imagine Adam without Barbara and Barbara without Adam. So this type of reaction, we can classify it as synthesis. We made a new compound. Let's go to scenario 2. Here we have Adam and Barbara walked into the dance as a couple, and on a dance floor they had a huge fight. And now they walk away, they separate ways. Now it's Adam without Barbara and Barbara without Adam. So what happened? How can we classify this chemical reaction? This we will call decomposition. Let's go to scenario 3. Scenario 3, we have 2 different things that can happen. So let's go to our first example of scenario 3. So we have Adam and Barbara walked in together. They are on a dance floor, and then Carly walks in. And Adam decides that he likes to dance with Carly, not Barbara. So now Adam and Carly dance, and Barbara is alone. That could be scenario 1. Or what else could have happened? Well, Adam and Barbara could have come together. They start dancing, and then Charlie walks in. And Charlie decides that he will have to dance with Barbara. So now Charlie and Barbara are dancing, and Adam is alone. This type of reaction with 2 different possibilities is called a single replacement reaction. And you can quickly see what's going on here. C was single at first in the beginning, and now B is single after the dance, after the reaction. Or here was C was single, it switched places with A, and now A is single. So the atoms which were by themselves are now switched places. Let's go to the 4th type of chemical reaction. And the perfect analogy is Adam and Barbara dancing on a dance floor having fun, and next to them is Charlie with Diane. Charlie and Diane are dancing having fun, and then they decide to switch. So now Adam and Diane are dancing, and Charlie is dancing with Barbara, and everyone is having fun. So what do we call this type of reaction? This one is double replacement. This one is our double replacement reaction. I think of it as the 2 boys switching places. And the 5th type of chemical reaction is combustion, where you have a compound rapidly combining with oxygen. Usually, the compound that will be given is a hydrocarbon. So it's a carbon-containing compound reacting with oxygen to produce carbon dioxide and water, to produce CO2 plus H2O. So this type of reaction is combustion. Combustion reaction. Let's go and actually, without talking about Adam and Barbara and Charlie and Diane, let's look at specific examples of chemical reactions. So synthesis, I think the easiest synthesis to think of is a synthesis of an ionic compound. Like, here is a nice example. You will have sodium, which is a solid. It's going to react with chlorine gas, making table salt, solid. And we have to balance this, yes, so we're going to quickly put 2 right here and 2 right here. And so now we have all the atoms are balanced. So it's a perfect example. You have a metal and a non-metal combining to form an ionic compound. Decomposition. What would be a perfect example of a decomposition reaction? Well, one of them would be, let's take water. And we can put electricity through it. We can do electrolysis. We can break it apart into its elements. Hydrogen gas plus oxygen gas. Now we do have to balance this chemical reaction. So here we go. I needed to have 2 oxygens and now hydrogens. Double replacement. Let's do a specific example of a double replacement reaction. A nice example would be, here is 2 ionic compounds. So we have silver nitrate and that's aqueous, that's dissolved and dissociated in water. Plus, let's do potassium chloride, dissolved and dissociated with water. And now the 2 cations will switch places. So we will get silver chloride. This will be my solid. And then we're going to get potassium nitrate. And this will be AQ. So it's just an example of a double replacement reaction. A nice example of a single replacement reaction will be if you have, let's say, silver nitrate, solution, and you're going to stick to this solution copper metal, copper solid, and then that will form copper nitrate solution, plus silver metal will be now by itself. And I do have to balance this reaction. So I need to have 2 in front here, and because I have 2 nitrates, and now I have to have 2 silvers, so it all balances out. And a perfect example of a combustion reaction is what you already saw. It's burning of methane gas. So if you have a gas burning stove, you have the reaction happening in your kitchen, where we have our carbon-containing compound is methane. It's a gas. It's going to burn with oxygen, also gas, to produce carbon dioxide gas plus water. I'm going to say gas because this reaction is pretty hot. So it will have to be gas before it cools down, and I have to balance my reaction. So I'm going to put 2 right here and 2 right here, and now my oxygens and everything has to balance. So these are specific examples, so you can see what happens. So really fast, we have 2 separate, for synthesis, 2 separate here elements coming together to form a compound. Decomposition, you have a compound being broken apart into its elements. Double replacement, think of this, our cations switched places. We start with 2 ionic compounds, and we end up with also two ionic compounds. But the cation switch places. Single replacement here. What happened? What switched places with what? Oh, it looks like silver switched places with copper. Here was my single replacement reaction. In combustion, my carbon-containing compound reacted with oxygen to form carbon dioxide gas and water. So let's see if we can recognize these types of chemical reactions. Can we recognize them? Let's think through what's going on. Okay, let's look at example number 1. I have two compounds before an arrow, and I have a bigger compound after an arrow. So two smaller compounds combining to make a bigger compound. So what do you think this is? I think it is a synthesis reaction. Did you get that? Let's go to the second example. What's going on? I have aluminum reacting with copper 2 chloride. Aluminum is by itself copper chloride ionic compound. And then reaction happens, and then after the arrow, I have aluminum is with chloride, and copper is by itself. That looks like single replacement reaction to me. Do you agree? So let's write single replacement here. Let's go to our next example. What do we have? Here we have an ionic compound, one ionic compound. Here we have a second ionic compound. We have silver nitrate and sodium chloride. And then we also have two ionic compounds after the reaction. But now silver is with chloride and sodium is with nitrate. Oh, that seems like double replacement reaction. Double replacement. Okay, let's keep going. Don't stop now. We're almost done. What do we have? I have a hydrocarbon, right? We have a carbon-containing compound, then it's reacting with oxygen, and it's producing water and carbon dioxide. Well, I think that's a combustion reaction. Combustion reaction. And our last one, last but not least, let's see what we have. Here we have calcium carbonate, and it's breaking apart into calcium oxide and carbon dioxide gas. So this seems like it's a decomposition reaction to me. Decomposition. Let's go here and talk about why do chemical reactions happen? What is the driving force for a chemical reactions? So today we only did a quick introduction just to expose you to 5 different types of reactions. In next series of videos, I'm going to focus individually on these reactions, but we need to understand why they happen. So there is 4 reasons why these chemical reactions happen. One of them is formation of a solid. Then we can also have formation of a gas. And also have formation of a liquid. And then a very important 4th last reason is transfer of electrons. In the next series of videos, when I explain these reactions, I will be coming back to what's the driving force, why do these reactions happen? So I hope you understand, you had a nice introduction to the 5 types of chemical reactions and are ready to learn more about them. Thanks for watching.